Alright, hello again, Jeff Scott of Blackhawk Technical College. I've been going over the PowerPoint presentations for Murox MySQL 2nd edition for the 152-157 Relational Database Development class for the spring 2016 semester at Blackhawk Technical College. As you can see, we're up to Chapter 15 out of 19. This is how to create stored procedures and functions. So let's begin. Alright, this will answer some of the questions that I had earlier for you, because it's going to tell you how to not only create stored procedures and functions, but how to call those statements so they do whatever it is you want them to do. How to code SQL statements that use user-defined functions, and a little bit on MySQL Workbench. Describe the process for validating data with a stored procedure or function. Describe the use of dynamic SQL. So here's the create procedure. So it's create procedure followed by the name, and then you can see inside of it, okay, whatever it is you want to do. And there'll be plenty of examples in this particular chapter. So what do we have here? We've got, as you can see, we've got a delimiter here, and so that is again turning off the special meaning of the semicolon. So we have a procedure. That procedure will have two variables, all right, an invoice ID parameter, which is an integer, and a credit total parameter, which is a decimal. So we declare our own local variable inside of the procedure for SQL error. All right, and notice it's a tiny int, which means it's going to be 0 if it's false and 1 if it's true. We declare a continue handler for an SQL exception. We set SQL error to true. So we're going to try to basically handle it if we get some kind of an error. All right, and then we start our transaction. All right, update invoices. We're going to set a credit total where this is the case, and if it worked, commit it. Otherwise, don't. So we say call followed by whatever it is. So let's see, just for the heck of it. Earlier we'd come in there and we'd written this. So if I call test, still doesn't like that. Thought that would do it, but it didn't. Like I said, fortunately or unfortunately, it's been a while since I've looked at some of this stuff. So, all right. So we've got that. And what I'm wondering is, let's do this just to satisfy my own curiosity. All right. Okay. Let's bring this up one more time. All right, let's just go back. So again, you see this is the name of your procedure. Update invoices credit total. You can also see that the procedure requires two parameters, an integer and a decimal. So when we call it, we have to provide those also, and it's call followed by the name. Now, when you're working with this stuff, just so you know, when you're working with this stuff, a couple things. First thing, notice when they talk about parameter types. You can have a parameter that's an in parameter, which means it's read-only. You can have a parameter that's an out parameter, which means it's write-only. And you can have a parameter that's in-out, which means that it's both read and it's write. Here's an example of two ins and an out parameter. All right. Here's a procedure that provides a default parameter value. If it's null, then set it to something else. Again, the idea behind this, what I want you to hopefully understand is this isn't all that different from the way that we set up writing, code in any language, programming languages, language that you've worked with. What's different is, first, the syntax is a little different, and second, you're dealing with database operations. So you're dealing with updates, inserts, deletes, selects, etc. All right. Next here they talk about a signal statement. Okay, so again, I'm in chapter 15, and the signal statement is on page 422. They mention on the top of the page here, when within a stored procedure, it's generally considered a good practice to prevent errors by checking the parameters before they're used to make sure they're valid. This is referred to as data validation. If the data is not valid, you can execute code that makes it valid, or you can raise an error. Figure 15.4, which is on page 423 in the book, shows how to raise an error using one of the predefined errors available in MySQL. To do that, you code a signal statement, followed by the SQL state keyword, followed by an SQL state code. Then you can optionally include a set statement that sets a message in MySQL error code for the error. They mention in this figure, for example, the if statement checks whether the value of the second parameter is less than 0. If it is, it raises an error within a SQL state code of 22003, a MySQL code of 1264, and a message that indicates that the credit total must be greater than or equal to 0. These SQL and MySQL codes are commonly used to validate parameters since they're used to indicate that the value is out of range for the column. Now, the thing to realize is this. With more and more companies today, their entire reputation is electronic. So if somehow they let bad data into the system, all right, that would potentially ruin the reputation of the company. And this has happened before, where companies have literally gone out of business because of this. All right? All right. So data validation is important, and it doesn't matter what programming language you're talking about, whether it is database stuff or not database stuff. But again, since databases are the lifeblood of many, many, many organizations, it is of paramount importance. It is of paramount importance that the data be validated and have it be valid before it goes into the system. All right. So they give some examples of what could happen if it doesn't. I do want to mention this, which is on the slide here. All right, because here they're starting to talk about dynamic SQL. Okay, now earlier we went and looked at an example, and in that example we hard-coded I don't know what it was, an invoice ID number or something like that. But the problem with doing that is when you hard code in values, every time you run the program, then essentially what's going to happen is you're going to have the same, since you have the same inputs, you'll have the same outputs. So what you'd like to do with dynamic SQL is you'd like to be able to write code, all right, and you'd like that code, you'd like to be able to come in there and pass in different data. So as it says, an @dynamic SQL variable at runtime. And there's an example of it right here. All right, so the idea when you use this, what is important about this, and the reason that you do things like this, is what you want to make sure is that you can run this and you can put in different customer numbers or ID numbers or different whatevers every time you run the program. And the reason, again, that you'd probably want to do something like this is just to make your life easier and to make whatever it is you're working with a little bit easier to use. All right, you're making the program, I'm looking for the right word and it's escaping me right now, but for lack of better words, you're making it more pliable. All right, you're making it easier to use. All right, if you don't want a procedure anymore, you drop it. You can check to make sure first if you not want to or need to, whether or not it exists. Okay, so those were procedures. Let's talk for a little bit here about functions. All right, and again, if you are following along, that brings us up to page 434. All right. And they mention on the page there that back in Chapter 9, we talked a little bit about the MySQL built-in functions. Now it says you learn how to create your own functions, also called user-defined functions or UDFs. It says if you've worked with databases other than MySQL, you'll be familiar with functions that return a result set. With MySQL, though, a function can only return a single value. This type of function is called a scalar function. In many ways, the code for creating a function works similarly to the code for creating a stored procedure, except, again, the fact that there will be a return statement in it, which will allow you to return a value. So as you can see here in the syntax, you code the create function keywords followed by the name of the function. After the name of the function, you've got the set of parentheses, where you can have parameters. After the parentheses, you put in the word returns, and you follow that with the data type that will be returned by the function. After you declare the return type, you begin statement, and that's between the begin and the end is where you're going to basically put all of your code in there. All right? To call a user-defined function, you use it as an expression because, again, you're returning a value. So it's very important that you do that and you do it correctly. If you're constantly writing the same, code to do the same kind of thing, and they give some examples, a function that returns a vendor ID. If you're constantly doing something like this, then you might want to set it up so that rather than you having to constantly be putting in the same code, you'd write a function so you can call it on an as-needed basis. Here's another example that calculates a balance due. And again, you want to be able to do this and combine some of the stuff that we've been talking about. And what I mean by that is you want to be able to put in there dynamic SQL also. So when you calculate a balance due, you can put in a customer's name at runtime and figure out what their balance due is. All right, when you're done with a function, you can drop it. And the last thing that's discussed in here, a function, again, something that's going to return a value, a user-defined function, one that you create. A scalar function is a function that returns only one value. All right? And finally, they show how this stuff is used and done in MySQL Workbench, which I'm not going over. So that's it. I'm going to come back in just a minute, and I'm going to talk about how to create triggers and how to create events.